Hi there, welcome to this video. We are going to talk about how to model a periodic context for AP Precalculus, which happens to be one of the questions in the formats for the free response question, specifically FRQ 3. So we're going to go through some of the examples, try a couple of practice problems, and hopefully prepare you for that type of FRQ. If you're in my class, this is lesson 7, and we're learning to create sinusoidal models. In order to be successful, you'll need to identify the amplitude, period, midline, and phase shift if applicable in a contextual situation. You can generate a sinusoidal sine or cosine function to represent the given scenario, and you can answer the contextual questions based upon the generated sinusoidal function. So, FRQ 3 is going to give you a context, and it will be a situation about something that will move in a circle or a wave-like motion, or something wave-like, okay? And this is what we call periodic phenomena, and it can be modeled with a sine or a cosine function of the form f of x equals a times sine or cosine of b of x plus c plus d. And something that's important to remember is that in circular motion, something that's going around, the midline is often the height of the center of the object that is rotating. The amplitude is often the radius of the circular object, or the distance between the center and the rotating point. Half that vertical distance between a maximum and a minimum, remember, is what we would call amplitude, max minus min, divided by 2. And the maximum can be found using your midline plus the absolute value of your amplitude. So d plus the absolute value of a, as well as the minimum can be found using, again, your midline minus your amplitude. Just something to remember, that one rotation is one revolution, which is equal to one cycle, and that is what we would call period. The horizontal distance between a maximum and a minimum is half of the period. So this is something that is kind of important to remember. So sometimes they'll give you distance between max and min. That's going to be half of your period. And another way to find period is this formula here, which I think is really important, is that period is equal to 2 pi divided by b. And if we go ahead and kind of do some cross multiplication and solving for b, the absolute value of b is 2 pi divided by that period. Okay, and then one last thing, a phase shift. If we have to do a phase shift, C can be determined by dividing the period by 4 in these types of lessons, okay? So we'll go ahead and look at some examples, but here are some general steps in order to help us with this lesson. Remember, they're not in a specific order, this is just general guidelines. First, determine the amplitude. Then determine whether A is positive or negative. For x equals 0, your first cycle begins at a maximum, A is positive. If the first cycle begins at a minimum, A is negative. If the first cycle begins at a midline, and then determine the next point to see if it's a maximum or minimum. If it's a max, A is positive, right, for sine function. If it's negative, then you're going to be going towards a minimum. Number 2, find the midline. Find the value of d, which is halfway between the maximum and minimum values. Number 3, find the period, p. Recall that period is one cycle or one rotation or one revolution. Number 4, find the value of b using either of these formulas. And then phase shift. Sometimes we don't need phase shift. If we're writing a cosine function and we're starting at a maximum or minimum, then we don't have phase shift. But if we're writing a sine function and we are starting at a maximum minimum, then we're going to have phase shift. But if we're at a midline, we don't, okay? And then the same, if you're starting at a midline and you're writing a cosine function, you're going to need phase shift. This is where C equals period divided by 4 will come into play. Okay, I've talked a lot, so let's go ahead. Let's look at an example here. And here is a situation where they say the blades of an electric fan rotate in the clockwise direction and completes 5 rotations every second. Point B is on the tip of one of the fan blades and is located directly above the center of the fan at time t equals 0 seconds, as indicated in the figure. Point B is 6 inches from the center of the fan. The center of the fan is 20 inches above a level table on which the fan sits. As the fan blades rotate at a constant speed, the distance between B and the surface of that table periodically decreases and increases. I want to go ahead and recap that and kind of highlight some important things that they say. This fan completes 5 rotations every second. That's important because that's going to help us with period. They say that point B is on the tip of one of the fan blades and is located directly above the center of the fan at t equals 0 seconds. That's important because it's telling us that our function is starting at a maximum point because this is going to rotate around. Okay, and then they say point B is 6 inches from the center. I think that might help us with our amplitude. And they say the center of the fan is 20 inches. Center of the fan is 20 inches above a level table upon which the fan sits. Okay, and so here is what they want us to go ahead and generate. They say the sinusoidal function h models the distance between B and the surface of the table in inches as a function of time t in seconds. So here's what's going to happen is here's your table, right? Here's your table, and we're going to go ahead and this function is going to measure distance, right? So when it's located directly above, right, that's going to be a maximum, and when it's directly in the middle, right, that will be the midline. And if we are at our lowest point here, then that will be a minimum. If it lets me write, minimum. Okay, so here's part A of FRQ number 3. They say the graph of H and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled, so you can see those 5 points here. And it says no scale is indicated and no axes are present. Determine the possible coordinates for t equals 0, t and then h at t for the 5 points. So this is what you have to do. You have to figure out the 5 coordinates. And I think on the AP test too, they give you like parentheses here, 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 and up here. And that's your goal. You can either write them in here or write them off to the side, but you just have to kind of go ahead and figure this out. So here's what I like to do first is I just like to label my heights. This is like what I like to do first. I like to say, okay, what's our maximum height? What's the middle height? And what is the minimum height? And so they told us, right, that the center of this fan is at 20 inches. 20 inches. So this is going to be a 20. And the fan blade, the point B, is 6 inches above the center. So when it's at the top, that's 20 plus another 6, right? So this distance, the midline, is 20. And then this distance right here is plus 6. Okay, the midline is going to be minus 6 from that 20. So I'm going to go up, right, 6 inches. So 26, and then down 6 inches. So we get 14, okay? And so what I've done there, just using what they give us as the midline and then the amplitude, is I figured out these y values. F and P have 26 as their height, right, their y value. So they'll have a height of 26 inches. G and K will have a height of 20, and the minimum point J will be 14. Okay, so we've got those. If you get all those, that's 1 point on the AP exam. And then next we have to figure out our t values. So how long does this take? So really, it's kind of interpreting, okay, at the beginning. And this is what I always do for this section is I say, okay, where is t equals 0? Where is t equals 0? Or can I plot a point? And they said, okay, at the beginning at t equals 0, the fan was at its maximum. It's located directly above, as in the picture right here. Okay, so there's t equals 0. And then next I have to say, okay, how long does it take for all this stuff to happen? And so this is where your period is going to come into play. They told us that we get 5 revolutions per 1 second. per 1 second. And so I don't want 5 revolutions. I want 1 revolution. So what I'm going to do is I'm going to divide by 5, and so here's our period. So we get 1 revolution, or 1 period. 1 period is 1/5 of a second, equals 1/5 of a second. Okay, so a couple of ways you could do this. I can make this 1/5. If you really like fractions, that could be 0.2, okay? And then I just have to kind of like backfill in, you know, these other values. So halfway between is going to be half of that distance. So if I divide this by 2, this is going to be 1/10, right? Divide by 2, multiply the denominator by that value, so 1/10. And then same thing here for G. I'm going to go ahead and, you know, divide by 2, so I get 1/20th. And the same thing here for K. So if I divide, well, what do I got to do? I add 1/20th plus 2/20ths, and then this is 3/20ths. 3/20ths. Okay, and there you go. That's how you get the second point, is by having your x values. Okay. All right. So with that being said, part B of this question is write a function. What's the function going to be? And they want it in the form of sine. So some things that don't change regardless of what type of function you're having is your amplitude and your midline. We knew from the beginning that our midline was at 20 inches, and we knew that our amplitude, our A value, is 6. And I know it's positive 6 because we're starting at a maximum. Okay? So I have that. That's generally what I like to do first. And then secondly is I like to identify what is our B value. What is our B value? And B is 2 pi divided by the period. 2 pi divided by the period, which in this case is 1/5. So it looks like we get 10 pi here for B. 10 pi for B. Okay? And then here's, I guess the last question is do I need C? Step 3, do I need C? C equals, do I need it? Well, you have to ask yourself, where are you starting? We're starting at a maximum. So isn't that a cosine function? Okay. But look here, do I have a cosine function that I'm writing? No, it's a sine function. So we have to go ahead and change our C value to move back, okay? And so our C value, which will be plus C, okay, moves us left. So in this case, C is going to be 1/4 of your period, and you can actually see it here. You already know this distance if you've done question or part A. Look at this distance. Didn't I go 1/20th, right? That's my C value. So again, period divided by 4, 1/5 divided by 4, we know is 1/20th, 1/20th. And there you have it. On the AP exam, they usually have a little box here that you fill in. A equals 6, B equals 10 pi, C equals 1/20th, and D is going to be 20. Okay, there you go. So, yeah, not too bad. All right, part C. I really like these ones. On part C, it's a multiple choice question, essentially. They say, refer to the graph of H in part A. The t-coordinate of K is T1, and the t-coordinate of P is T2. On this interval, which of the following is true about H? And they say H is positive and increasing, negative and increasing, positive and decreasing, negative and decreasing. You have to select one. So let's go ahead and look K and P. So we can look up here, K and P, and we're essentially being asked about this section of the graph here, okay? So the first question, is it positive or is it negative? And this is H. These are your Y values. So just look at your Y coordinates. Are these values positive or they're negative? They're positive. Most of the time they're positive, unless you're like underwater or going down underground, you know, it depends upon the context. But we're definitely positive. So I can throw away C and D, And then we want to know are these values of h increasing or decreasing from k to p, And look, we're going up, so that means we're increasing, going up. Y values are positive, and they're getting more positive, so answer is going to be A. There you are. Part 2. Part 2 does require some wording and explaining. They say on this interval, describe the concavity of the graph of h and determine whether the rate of change of h is increasing or decreasing. So we really want to know what is the concavity here. So we can look at our graph. Okay, we can look at our graph here from K to P, and we can see this is concave down. Concave down. So we can say on the interval T1 to T2, H is concave down. H is concave down. And the second part really is the same question. Is the rate of change of h increasing or decreasing? Well, by definition, if you're concave down, rate of change is decreasing. Like look at this graph. Look at my average rate of change. Isn't it getting flatter and flatter and flatter until we get to P up here? It's 0, right? So concave down by definition is rate of change is decreasing. If our graph was concave up, it would be rate of change increasing. So pretty easy to remember here, okay? So on the interval T1 to T2, h is concave down, and we can say, and the rate of change is decreasing. Okay, there you have it. So this video is getting a little long. I'm going to stop here. I think the first example really required a lot of explaining, and then just kind of our intro sucked up some time. So I'll make a second video where I do example 2, and we have some practice problems. Make sure you watch those. But in this video, you should have looked at FRQ 3, which models a situation which is periodic phenomena. Okay, so something moving in a circle or in a wave-like motion. Okay, please give this video a thumbs up. Watch part 2 for another example and practice ones. You want to try those practice ones. Catch you next time.